So I want to review with you guys what we learned the other day about function notation, since I'm not there today to answer any questions. So just a quick review. When we do something like this, that tells us that we're talking about a function that involves both an x and a y, but we always start with the x because the x is the independent variable, or the input, if you want to call it that. You may also know that the x is called the domain in a function. And then what's going to go on over here could be an expression, how to figure out the answer. But in the end, basically, it is the y. And what we know about the y is that that is the dependent variable. It's the output of the function. If we start with the x, we fill the x in, we work out the problem, we get y. So y is the output. And how x is called domain, y is called range. So you may have heard of that term before. But we worked on the other day a task where there was Fiona and her mother Julia had her height measurements on the inside of a closet in her grandmother's house, and it said something like this, and I'm just making this up because I don't remember what the exact numbers were at all. So let's say it said something like this, and we learned that this is just a shorthand way of saying that Julia at age 3, because age was the variable for the x, was 32 inches tall, and that was because the height was the y variable. So this is saying Julia at age 3 was 32 inches tall. I also told you that what this ends up transferring to is an ordered pair, which would be 332, which then we could go and graph the point 332 among the other ones. So all of this is related because this right here, function notation, tells us that that is the number that we used in place of x, and this is the answer that we got, which we, up to this point, usually would say y equals whatever. So now what we can do is use this instead of the y. That way we can see what function we're doing, what number we filled in for x, and then we can get the answer. From there, that becomes an ordered pair that then could go onto a graph. So some things that you're going to look at today is all of this, but perhaps in a different setup. And what I mean by that is if you had a graph, and let's just say it does something like this. Let's say this up here is 10. We'll call this 5. We'll call that 5. We'll call this 10. We'll say that's 15. So just to put some numbers to it. If I was asked to find this, that tells me that my x is a 5. So this right here, remember, is the x. So I know that f of 5 is going to equal something, and I know that something is the y, which then would transfer into an ordered pair, which would be xy. So I know that if my x is 5, and I look right here, and I go up, the point right here is the point 5, 10. So that must mean that if I filled in 5 for x, I got an answer of 10 for y. All right, another example might be maybe I was asked to find f of x equals, we'll say 5. All right, so I'm asked where on this graph does, because remember that's the x, this right here is the y. So where on this graph is the y 5? Well, technically speaking, the y is 5 right there, and right there, and right there. So I could say that when x is 0, y was 5. I could say when x was maybe, I don't know, maybe that's 8. When x is 8, y was 5, because of that point right there. Looks to me kind of like the 0.85. Or this one right here, maybe when f was 12, y was 5. Because all of these right here coordinate with ordered pairs on the graph. So if this point right here is 12, 5, then the function that I was using when I filled in for 12, I got an answer of 5. So that's using a graph to find function notation. Now what you guys did the other day was to work with some equations, so you're still going to be doing that. So let's say, for example, that f of x is 3x minus 1. And let's say h of x is negative 2x. So if I was asked to complete a problem, maybe h of 7, that tells me that I'm going to use this equation, because this is the equation that is identified as h, which could stand for height. It could just be a random variable that was chosen. But I know that this is the equation I need. I'm filling 7 in for the x. So then that means this needs to be negative 2 times 7. So now I know that when I use the h equation, filled in 7, the answer is negative 14. And then again, that can be changed very easily into an ordered pair. All right. Okay. If I was asked to do this one, now I'm using this function because I'm using the equation labeled f. I'm filling x in with negative 1. So this is going to equal 3 times negative 1 minus 1. So that tells me that when I used the function labeled f and I filled in a negative 1 for x, I ended up getting an answer of negative 4. So this could become the ordered pair negative 1, negative 4. So that's a quick review of what we did on, I guess that was Tuesday. The only other thing I want to mention, and this was something that you talked about last year, was if something is a function, just keep in mind that that means that all of the x's are different. So there's no duplicate in any of the x's. So in a function, we say that all x's are unique. Okay, there's no duplicate in your x's. It doesn't matter what the y's are, but the x's cannot be used more than once. All right, I think that covers everything so that you'll be able to work on the packet that I left for you.